All right, here we go. Question number 12 from our 1316 homework number 2 in MyLab Math. They want us to find the amplitude, period, and the phase shift of the function. Then we're going to have to graph the function. Be sure to label key points. I don't think that's going to be required since we're going to be graphing electronically, and show at least 2 periods. It's just going to show as much as the graph allows us here, okay? But when we do it by hand, I'll try to follow those criteria. Here we go. The first thing I want to do is give you the standard form of a sine function, and that equation is y equals a sine of bx plus c. That is your standard form of a sine function, and we can see that the value of a is 5. The value of b is 2, and the value of c is negative pi. And so from that information, we're going to be able to find our criteria, what they're asking for, okay? So here's what we know. We know that a is 5, and we know that the amplitude is the absolute value of a, and the absolute value of positive 5 is still positive 5. So that should be our amplitude. Our period, okay, so the period function for sine or cosine is 2 pi over b. That is the formula for the period of a sinusoidal function. And our value of b is 2. Here the 2's are going to cancel. And so our period, our wavelength, is going to be pi. And the phase shift. So in a sinusoidal function, the phase shift formula is negative c over b. Here we can see that our value of c is negative pi. So when I plug into the formula, it's going to say minus negative pi over 2, but minus a negative makes it a plus. So we're actually going to have a positive phase shift. And if we input that, pi over 2. So we're good so far. Now we need to go and graph it, okay? So instead of graphing it electronically first, I think what I'm going to do is graph it manually first and show you how to do that by hand. And then we'll go through and look at graphing electronically, okay? So we're going to follow the 6-step method of graphing a sine or cosine wave. Step number 1 is the starting point, and the starting point is determined by your trig function. So sine always starts at the origin. Cosine would start at the value of a, whatever a is. So our starting point is going to be at the origin because we have a sine function. That's step number 1. Step number 2 is phase shift, okay? So since we have a phase shift, that tells me that we're going to have to scoot this starting point over to pi over 2. So our phase shift is going to take the starting point and shift it over either positive or negative. In this case, it's positive pi over 2. And that's step number 2 is to take care of the phase shift, okay? Step number 3 is the wavelength, which is the period, okay? So I need to travel a distance of pi from start to finish. And I'm starting at pi over 2, and I need to travel a distance of pi. So here's my question to you. How many half of a pi's make a whole pi? And if you're wondering why I ask that question, anytime you're doing a sinusoidal function, you're always going to count by the phase shift to equal the period. And that'll tell you how many spaces to go. So if I'm starting at pi over 2, I need to go 1, 2 spaces, okay? So this is a half and a half makes a whole. That'll be a whole pi. But then if we count from the origin, that's going to be 1, 2, 3 halves. And so that's what I'm going to label this hash mark. This hash mark is going to be 3 halves because each one of these spaces is a half. Again, 1 half, 2 halves, 3 halves, and then the distance from start to finish here will be 1 pi. And so that's the third step, is to determine our wavelength. And I don't know if you may have heard me say this in a previous video, but you always finish where you start. So if I start on the x-axis, I'm going to finish on the x-axis, okay? Step number 4, I need 4 equal spaces. So I'm going to have to cut this in half and cut this in half so that I get my 4 equal spaces. That's step number 4, 4 spaces. Step number 5 is lay out your points. And the original value of A, the original coefficient is positive. So that means we're going to go up to 5 at the first hash mark, okay? If this 5 here would have been negative, then at this first hash mark, we would be down at -5, okay? But it was positive, and so that means that we're going to be up at +5 first, okay? So I'm going to go up, and that's that part of the curve. And that maxes out, so then I have to head back down to get this part of the curve. And then we're going to go down to -5 at the next hash mark. And then at the next hash mark, we're going to be back at the axis, okay? So that's one period. That's one wavelength. If I want another wavelength, I'm just going to count another 4 spaces. 1, 2, 3, 4. And I'm just going to continue the pattern, okay? Going up, down, down, and up. And I make another wave here. Wave. Now it's supposed to look sort of curvy, okay? Bam. Now, let's figure out what some of these points are. So if this is a half and I go back, this would be a fourth. So every one of these hash marks is going to be a fourth of a pi. Got that? So a fourth and a fourth is a half. 1/4, 2/4. So this point here would be 3/4, and 5 would be this point up here. Another fourth would be 4/4. So this point would be pi comma 0. That's 4/4, okay? Another fourth would be 5/4, and that's going to be at -5. And then at 3 pi over 2, we're at 0 again, okay? So what is 3 pi over 2 in fourths? 6/4. So this ordered pair here would be 7/4 up at 5, 7, and then again here we are at 8/4. What is 8/4? 2 pi? We're back at 0. 9/4. We're at -5. And then 10/4, which reduces to 5 halves. We're back at 0. So you can actually label every one of these critical points, knowing that each one of these tick marks is a fourth of a pi. And that's how you can get those critical points. Now let's come over here. I spent a lot of time on that. I'm sorry. Let's come over here and graph electronically. So we're going to know, let's see, we know this is a sine function. So we're going to grab the sine tool and click, and we're going to increase our amplitude to 5. We're going to change our period to pi. We do not have a vertical shift. We're not going to mess with vertical shift, but we do have a phase shift, and the phase shift is pi over 2. So we're going to type in the letters pi. If you type in the letters pi, you get pi, and then divided by on the keyboard, pi over 2. And we do not have a reflection across the x-axis. If our original a value was negative, then we would need to reflect that across the x-axis. Okay, so that should be good. And if we scroll over here and look at what we've got, if I finish this back to the origin, going down and then back, you can see that this wave should go through the origin and go down first and then up. And that's exactly what our wave does over here when we graphed it electronically. And we're going to check, and we're done. Man, I hope that was helpful. If you have any questions or comments, feel free to put those in the comment section below, or you can text me. And thanks for watching.